All right, so good morning, students. So the previous one, I just sent a short 15-minute video just to summarize on the data pre-processing part. Now we are actually following in the pipeline of the data science pipeline, which is first is of course we were looking at the data acquisition, and then we looked at data pre-processing, and now we're going to look at the exploratory data analysis aspect of it. And here, under this exploratory data analysis, we'll also have one project, so which we'll do as a class activity. So once we are actually almost towards the end, then we'll take the 2 hours class, and we'll do that as part of the class activity for you to actually work through the entire cycle. So is that okay? So upon acquiring your data, the data pre-processing is involves a lot of things that we have actually done. But later on, as part of your project one, we will do some really hands-on examples that we will actually do before your project one. Okay, so we are looking at exploratory data analysis. I couldn't go in the slide mode. I think some settings is a bit different. Let me just try to check it. So of course, previously we had looked at the data pre-processing, right, which is one of the data science pipeline. Now, the next thing is, of course, after we get the pre-processed data, the next big step would be, of course, to choose the machine learning algorithm to model the data. But before that, we have to try to understand the data, right? Like, for example, what is the structure of the data? What are the attributes? How many rows and columns? How's the distribution like? What are the test assumptions about the data? What's the distribution is like? Which part of the attributes that you want to, what do you want to do with the data? Because later on, do you want to make some predictions or do you want to classify? So based on your data, what type of data is that? Is it categorical? Is it numerical? What type of data? Based on that, because you need to know all that before you can actually apply the machine learning model. So later on, we have a very nice chart to illustrate when you have this type of data, what kind of machine learning model that you can actually apply. How do you actually select the features that you can actually use for machine learning methods, and how to choose the suitable machine learning models for our data set. So that's where the exploratory data analysis comes. So you are trying to explore and try to understand the structure and also the important part of a data set. So of course, when you do exploratory data analysis, you will have some visualization as well. And it will give you a good understanding of what the data actually contains. So of course, when we say exploratory data analysis, meaning to say that we are actually exploring the pre-processed data, and we are using some visualization tool and to understand its salient features and important patterns. So some of it we have already explored a little bit, like for example, describe. Earlier in our pre-processing, we have done the describe, right? So you can actually see the distribution of your data. So that's also part of exploratory data analysis, trying to understand how the distribution is like. So once you have actually done this EDA, then you can actually go on and perform on the modeling part, which will be the next subtopic after this, the main topic after this. So you know whether you want to perform clustering, or you want to perform regression, or you want to perform classification. So what is the goal of EDA? It is actually to make sure that the data set is actually ready to be deployed in a machine learning algorithm. And it is a very, very important step in a data science project, and also in terms of validating the results and also making the interpretation much more easier when you actually get the results. So we will do some practical examples here. On another note, starting from today onwards, I will be sharing some important topics that will be relevant for your finals. I will not make any recap towards the end of the semester. So those who come for class, they'll be able to capture that. Of course, in this case, it's being recorded, but sometimes it may be recorded or may not be recorded. So it's for you to actually pay attention and also take note of what are the important topics that are relevant for your finals. So revealing structure of data. So this is important. This is very important. So when you know your structure of your data, it actually enables you to use the appropriate machine learning methods. So in exploratory data analysis, there are several techniques. These techniques are very important. So there are three. First one is univariate, bivariate, and also multivariate visualization. So make sure you know all this. It's very important. So you make sure you know what each one of these are, what is it used for, and give some examples as well. So univariate visualization, this is from the name itself is univariate, which means you are actually generating summary for one feature or one variable in a data set, right? And how you summarize it, you use some descriptive statistics, like for example, how we have done before, you use the mean, median, and also describe. So this is also known as data profiling. So what is the goal of univariate? It's to have a solid understanding of the data, how the distribution of the particular data is, like if it's numerical number, if it's a categorical, what is the frequency of each category. But you're only focusing on one, univariate visualization. You're just visualizing on just that one particular feature or attributes in a data set. Is that clear? And what type of visualization tools that you can actually use? We have actually used this before, right? Bar plots. Remember when we, what was the previous example that we did? The age, right, of the student. We are only focusing on one, univariate. And based on that, what did you actually find? Based on age, we actually did some sort of exploratory data analysis. So what did we find about the age? Do you remember? So I just finished explaining about the outliers. So it's not mentioned in the recording. It's only those in the class, for class discussion was there captured. So the univariate visualization is that one example, right? And how you can actually use it for a single variate, single attribute, well, you can just use bar plots or you can use histogram, right? It's only one. That's the most suitable one for univariate. Now for bivariate means what? So bivariate now is, by the term itself, you know, it's bi, right? It's two. So to find out the relationship between two variables. So whenever you have bivariate visualization, you want to find out the relationship between two. So how you actually can do it, you can use correlation. We will later on in this chapter, there's correlation. You can also view as a scatter plot and also line plots. So whenever you use the line plots or scatter plots, you can try to see the relationship between two. Is it clear? Are you able to understand the difference between the univariate and also bivariate? Univariate is just looking at a single variable, even though you may have x and y axis, right? But the x-axis is only for one variable, and the y-axis is the value of that particular variable. Like for example, you have age. X-axis is only age. What is y-axis? The range of age. That's all. Are you looking at relationship between other attributes? No. But in bivariate visualization, maybe you'll be looking at age and also the class, for example. Now you have X and Y are two different variables, and now you're looking at the relationship between these two. And then, of course, you have multivariate visualization. So this one is to understand interaction between different fields in the data set. So we will also do this as part of in this chapter. So of course, it uses line plots, scatter plots, and matrices with multiple colors. We can later see that we use the correlation matrix so that we can try to understand the relationship between various features in a data set. So this is univariate, bivariate, and multivariate visualization. Is all okay? Is there any questions that you have? So please download this value. I'm just, this value. Download this file. This is the URL link. Download and keep it in the same folder. And this data set has the following columns or attributes and also the description. So later point of time, whenever you are doing or searching for data, you should also evaluate and try to understand what is the data set attributes are. So here I think it has 7 attributes, and there's a description of what each attributes are. So before we actually explore on the data set, let us do some basic import some important libraries, and as well as do some basic plotting. We have not done that yet, right? So in order for this, of course, we are going to use NumPy, numerical pi, and also we'll be using pandas. But on top of that, because we are having visualization, so we're going to use matplotlib and also seaborn. These libraries allows us to actually have a nice visualization. So for that, we're going to have import numpy as np. This is the standard one, and we're going to also import pandas as pd. This is something new. We're going to import matplot library dot pyplot as plt. This np, pd, and plt actually can be any name, but this is standard names that has been used. And you're gonna import seaborn as SNS. So seaborn has some advanced features of plotting, so we can actually use both together as well. So make sure you run this. So you've imported that, so not a problem. So now let us actually look at the plots and also charts. The first one, we will look at the line plots. So line plots are very easy, simple line plots. So, but let us try to generate a simple line plot. Let's put my phone in silent. So let us actually try to create 2 coordinate values. X1 equals to, let's create a value of 1, 2, 3. And we create y. We're just going to do a simple plotting, 2, 4, 1, for example. So this is like coordinates, x and also y. So the first one is x is 1, y is 2. The second one, x is 2, y is 4. The third one, x is 3, y is 1. Understand? So we are going to use the plot function. This one is just simple x and y coordinates. Here we're going to plot the line chart. So in order for us to actually plot, we're going to use the PLT. This is the how we actually define the matplotlib plot, right? So you use that plot and you invoke the plot function, and this plot function requires the input argument. Of course, it requires the x value and also the y value, and you can also set the label. So let's say you can just say this is line 1, for example. So this code will plot using the x and also the y values and set the label as line 1. But if you run this, nothing will show out, so you have to use plot and show. Sorry. Then it will show the line chart. So this is a simple line chart. You can see the first one is 1, 2, then 2, 4, and then 3, 1. Right, a simple line. It's not showing the label. So of course, in this graph, we actually generate 3 values. We have actually generated that 3 values. Later on, there will be some exercise for you to do. So you need to generate the plot and show. So to generate a line plot, we actually call the function plot. So by default, the plot plots a line graph. And you need to pass the x and y axis. So remember that we are using the PLT as an alias for pyplot. That's what we have defined it. So we can also add titles, labels, and also legends. So how can we actually do that? So we use another set of, or maybe we use the same one. The same x and y. Now we can just copy paste the entire thing. So this is the same thing. Plotting the same, but we remove the plot show. This will keep it at the end. So we can actually also name the x-axis. So again, this one we use the plot PLT, and this one we can put as x label. So what is the x label that you can actually set? You can actually put as x-axis. So whatever you put inside, and the same thing you can just. Why you're not telling it's too small? Give feedback, yeah, so then I know. I don't know how you all seeing. The LED light is quite bright, so that's why it's also difficult. So do give me feedback because I'm seeing my monitor. For me it's okay, but then on the screen maybe it's small. This is better. So again we're going to do the plot also for the y label. So this one we put as y-axis. And now let's try to give the title. So it's easy, yeah? Easy in the sense that when you actually put the plot function, you need to give the x and y, then you set the label. And then how do you actually name the x-axis? By using the x label, and y label. Title is using the plot title. So this one, again, my line chart. Okay, earlier why the label didn't show is because we didn't use another one more function which is known as legend. You need to invoke this legend so that it will show your label. Basically labeling the line, but it didn't show earlier because we didn't invoke this. And finally you can do plot show and it will show your chart. So now you see, yes, it actually labels the line right under the legend. So you can see the title is there, y-axis is there, and x-axis is there. Is that okay? Any question up to this point? Everyone managed to generate it? So let's try drawing multiple plots. So this one we will just use example of, yeah. Okay. So we can actually we can generate, you can try to overlap two graphs on one. So for this example, we'll use a cosine function and also a decaying cosine function, and we'll try to overlap these two. So don't worry too much about the equation of the cosine function. It can be any other function as well. You can actually overlap two line charts on top of each other. So here, let's say, for the sake of example, we are going to create the range of x value. We're going to use the numpy range function, and we're going to create the values. You can just follow this equation for now. Basically, this is because we are working on cosine, we are trying to get the angle range and using 0.1 step. This is basically to tell the resolution of your x-axis. When you plot the graph, this is the resolution of your x-axis. We're just doing this for the cosine function, and the y will be the cos. So why we are using NP numpy? Because numpy is a numerical pi, right? All this mathematical function is actually derived from that numerical pi, and we're going to pass the range of values of x into the cos function. This is in radian, so you'll get the cos function, you'll get the equivalent y value. So this is, this is a cosine function from NumPy library, this one. So let's say if you want to plot the points, what's the instruction that you use? plt dot plot, right? You use a plot function, and what are you going to plot? x1 versus y1, and you can actually put the label, right? Same like we are doing the same thing like how we did before. This is a cosine, and let's say we want to put together with the labels as well. So plot legend, what does this do? If I put plot legend, what it will show on the chart? The label, yes, it will show the label. How can we actually name the x-axis? Dot x label, right? So we can name this x label, as angle, and we can rename plot y label as amplitude. Now, so just for us to see, plot show. I see it actually shows this plot. This is the cosine function. For every angle, it gives you the value, right? every point. That's why you get a smooth line, because you're doing for every 0.1 values of x, you are passing it to the cosine and you are able to get a nice flow. If you're doing it every 1, so that means 0, 1, you'll see like sharp lines. But if you're doing it like every x 0.1, you are actually finding what is the y amplitude value. That's why you get a nice curvy lines. Okay, so anyway, we'll remove this. The moment you put the plot show, it actually will show the plot. So but now remember that we want to have two on top each other. So therefore we will keep this plot show at the end. So let's generate the x and y for, let's copy this one. Copy this one for the second plot. But this one, now we will use the decaying cosine function. This is same, x 10 0.1. So this one will be now, this one will be known as x2 and y2. This will be x2. But now the equation will be x2 and we will be multiplying with 0.1 times with pi, times with all the range of values, and you have multiplied 10 with the pi. You take the value from 0 . This is the formula for decaying. Let's plot and see it's correct or not. So plotting the points will be the same as above. So I'm just going to copy. But this one will be x2 . This will be x2 and this will be y2. Now as I mentioned again, don't worry about these two equations. These are actually decaying cosine equation and also equation. This could be again the same like how we did earlier to get a normal line chart. This one also you can have the same coordinates also. But the whole idea is to show how you can actually plot two together. This x1 and y1 and y2 and x2 and y2 are simple. It can be any equation that you can put. But this one will be labeled will be decaying cosine. And this one you can actually plot. So one you want to put legend as well. Gives title to the plot. Do we need to do plot? Do we need to put the x label and y label? What do you think? Do we need to define x label and y label? It's already done here, right? So remember that when you do the plot function, it plots with this value and it labels, it has that label. When you mention plot legend, it creates a legend for this. And of course, you have already created the x label and y label. Now you're creating the second plot, which has these two values. Of course, you need to plot them and also assign the label for it. So now you don't have to redo back x label and y label because they are the same. So you just also make sure you do the plot legend so that it will show this legend as well, right? And then you include the title. Title, whether you put here or here, anywhere you put, it will appear the same. So now you show the chart. Now the chart looks a bit different. Maybe something wrong here with the equation. Alama. Wonder. This is not plus, this is times. My bad, my bad. That's why the chart looks funny. Anyway, you can see how you can have two plots, right? But sorry, this one is not plus, it's actually multiply. Now you should be able to see. Yeah. The whole idea is to you are able to plot two, right? You can do more also. Is that okay? Now with this background, so we have learned about the plot function, use the X label, plot show, add the title and also legends. So these are the things that we will be using for our visualization. Okay. So now before we are going back to that, have you all uploaded that file into your directory? So let's try to read. Oh, it's 11:45. So let's call this as housing price, and we are going to use the pandas library, which to read the CSV underscore CSV, and you need to provide the exact name of the file. What's the exact name of the file? USA housing, right? What file location? So it's going to be the exact name. And make sure you write the extension. Now, do you all remember what is the function that we use to have an overview of that data set? The first few lines that you want to view, because sometimes whenever you are loading data, right, you want to have an overview. What is that? Do you remember? We have used the function known as head. So when you use the function known as head, it will give you the first few entries. I think 5. The first 5 entry. If you use tail, give you the last entry. So why we are actually doing this? So let's go back to head. Just to have an idea of how your data frame looks like. Just an overview. So you can do the same for the tail also, which is the next line. There's a space kept for that. So you can see that this is the index 0 to 4. You can see this is the index. So that means it has around like 5,000 data, right? How do you know, how you want to confirm whether you have 5,000 data or not? You can actually use another function which is known as shape. So what does the shape tell you? There are 5,000 rows and 7 attributes. And use the shape. So remember this, the head, tail, shape. So when you shape, you don't have to put the bracket. It's not a function. It's a built-in thing. And there's another thing you can also do is it's known as house underscore price dot info. This is a very useful thing, the info function. Now this info function will actually give you the range index and also how many, what is the type. So you can see that how many columns are there. It gives all the column names. and it also automatically will give you the non-null count. So in this way, what can you actually find out? You can actually find out and see, right, whether just now when we did the housing price shape, you managed to find the 500 rows. But when you use info also, it shows you that 500 entries, you give you a range 0 to 499. So, and you can see that, are there any missing values here? Are there any missing values? Nora, you can see no non-null count is 5,000. That means all the data are in place. And you can also see the type. So float, which means what? All these are numerical values. Address is object. So it's actually a string, right? Address, it has address. So we'll continue in our next class. I'll just stop the recording here. I want to return back your exam paper.